So in order to make sure the fun doesn't stop here, let's take a look now at doing some calculations on a rafter, the worksheet I just handed out to you. So we are looking at a 2x4 wall, a 2x6 rafter, set on a 412 slope. This is a 1.5 inch, or there's a 2x ridge brace. It's not a beam because it's not supporting any weight if it's only a 2x. It is just a ridge connector is all it is. On a setup like this, all the weight is considered to be held on the wall, so you're going to have a very good ceiling joist serving as collar ties to keep your walls from spreading on you. We have a 2-foot overhang and a 10-foot span or run on this, not span, but run. So the first thing I want to find here is I want to find A. Now, unfortunately for A, it's not as easy as it looks. Why would it be, right? This distance down here is 10 feet plus 2 feet minus half of my ridge brace. So in other words, minus 3/4 of an inch. So here's what I'm going to have to do in my calculator. I'm going to do 10 plus 2 is 12 feet. But I'm going to subtract out 3/4 of an inch. So I'm going to subtract out 0.75, but that's inches. So to convert it to feet, I'm going to divide it by 12. So that's 11.9375 feet. That's my run. Now to find my height here, I have a 412 slope on an 11.9375 foot run to find my height. So I cross, multiply, and divide. So I take that 11.9375 times 4 divided by 12 gives me a height of 3.98 feet. So then A is just the hypotenuse of that triangle. So the length of A is going to be the square root of the 3.98 squared plus 11.9375 squared. So on my calculator, I'm going to do second square root, and then I'm going to just take that answer squared plus 11.9375 squared. 12.58. 12.583 we're going to go. So 12.583 feet. Eventually, yes. You guys can do that conversion, though. So I'm going to leave you guys to convert that feet, inches, and sixteenths. We've done that enough at this point. That should be pretty automatic. Now, of course, that is not the overall length of that rafter, is it? Why is it not? Well, that's the length to here. We still got the cut, the plumb cut for that tail, right? It's not a square cut tail, it's plumb cut, perpendicular to the ground. So we've got to figure out what extra distance that would add to it. That's the dimension B that we're asked to find. This is a right angle here. This here is how big? It's a 2x6, that's 5.5 inches. This angle right here is going to be equal to this angle right here. Do you know what? See why? Because this is a right angle, this is a right angle. They're both complementary to the same angle. Both of them are complementary to that angle there. Because you got a right angle here, and another right angle up here. So this one is the complement to both of those, so they have to be equal to each other. And this one down here is just the heel angle. So this one is just going to be the inverse tangent of 4 over 12, which is what, 18.3. Second tangent, 4 over 12, 18.43. This is 18.43 degrees. Yep, so this one's the same thing right here. So what we have now is B is the opposite side. So we're going to have tangent of 18.43 degrees equals B over 5.5. So we'll cross multiply and divide to find B. We get that B must be 1.833 inches. So there's B, 1.83 inches. Again, that's in inches. I'll leave it to you to convert the 0.8333 into sixteenths. The greater the slope, the longer that's going to be. Smaller the slope, the less extra you have to have. The greater the slope, the bigger that's going to be. So now, X is our 12.583 plus 1.833 inches is going to be doing what? I have to take that divided by 12 to convert that into feet, which is 0.153. So this is 6, 13, 7, 12.736 feet is what X comes out to be. That is the minimum length of the whole board that we're going to cut that rafter out of. Next, we're going to look at our bird's mouth. Our bird's mouth, of course, this top piece of the bird's mouth is 3.5 inches. Because we're doing a 2x4 wall. If it's a 2x6, it'd be 5.5. No. The reason why I did a 2x4 wall here instead of 2x6 is if this were a 2x6 wall, this piece here would be just the same as B up here. It's this piece. They would be the same because they're working off the same angle. So I had to switch it up and make it a 2x4 wall. So this angle right here is still 18.43 degrees. That's off that heel angle. When you're dealing with rafters, almost every angle is either equal to the heel angle or a complement of the heel angle. Just so you know. So then this one over here is going to be 1.167 inches is that dimension. So again, I'll assume you guys can convert that into sixteenths. Z then, how do we find Z? Z is, if you have the board here, Z is the distance from there all the way up. Why is Z important? Because Z is a structural dimension on your tail. All the stress of your tail is going to be held on that width of Z there. What's that? Yep. So now we got to figure out what this whole height would be here if this were 5.5 inches. So this is what we're looking at. This is 5.5 here, 5.5. This is the 18.43 degrees. To find this whole distance would be a cosine. Cosine of 18.43 degrees equals 5.5 over, I'm going to call that y for now. Oops, I already used y, so I call it something else. We'll call it w. So I'm going to put this over 1. So W is 1 times 5.5. So it's 5.5 divided by cosine of 18.43. 5.797 minus, because that's the whole way, and we know this bottom piece here we just calculate to be 1.167. So we subtract that to get that this is 4.630 inches. So Z is 4.63 inches. That one wasn't so bad, was it? So you guys need to make all the conversions into inches and sixteenths, feet, inches, and sixteenths for any of those. What do you think?